Alright, so today we are looking at section 10.2. You should have the notes that look exactly like my notes up on the board. We're going to fill them out together, and then you'll have the rest of the class to work on your homework. So this is all about proportions. And our goal today is to solve proportions by cross multiplying. Alright, so the first thing we should probably talk about is what is a proportion? A proportion is a statement that has two equal ratios. So yesterday we learned what ratios are. Ratio is a comparison of two numbers. Today we'll still be comparing two numbers, but it's done twice with an equal sign in the middle. That's what makes it a proportion. So you have two ratios and they're equal to one another. So we're going to start by looking at how to tell if a ratio is true. Or sorry, how to tell if a proportion is true. So basically you have to decide, are the ratios actually equal to one another? So there's two ways to do this. You can simplify the ratios and see if they equal one another. Or you can use the trick that we're going to look at in the next section. I'll show you that in a minute. First, let's reduce. So, can anyone tell me what 8 over 12 equals? You can use the ABC button on your calculator. So 2 over 3? So I am just simplifying or reducing each ratio. So the first one, 8 like over 12 dislike, simplifies to 2 like over 3 dislike. Now simplify this ratio and see if you get the same thing. That one gives you 5 over 6. Do those equal one another? They do not. So determine if the statement is a proportion or if it is a false statement. You can say yes or no, or you can say false statement. I usually just do yes or no. Is it a proportion? No. Alright, another way to do it, I'll just show you because a lot of LS teachers like to teach it this way, so I'll just show you so you know what they're doing. Another way to check is to cross multiply. When you cross multiply, you multiply across the equal sign, starting at the top of one side and going to the bottom of the other side. So I want to do 8 times 24. Can anyone tell me what 8 times 24 equals? 192? Let me make this a little smaller. Alright, so 192. Multiply across the other way. What is 12 times 20? What is it? Do those two equal one another? No. If this was a true proportion, these two numbers would be the same. Or when you reduce it, the two ratios would be the same. Either way, it's not a true statement. Okay? This is a false statement. Any questions on number 1? Or you could just look at it and know? Is that what you said? Yeah, cross multiplying is fine. I like to show you both ways, give you some options. I just answered that. You don't have to do, you can reduce, you can cross multiply, either way. Any questions? All right, let's check out number 2. Any suggestions on how you want to do number 2?
30 over 25, 125.
Okay, so you want to reduce 30 over 25? What do you get?
625.
6 over 25, okay? Did you reduce the other side?
Yep.
What do you get?
25.
Same thing? So is this a proportion? Yes, it is. We'll just say yes. Technically, if you were answering the question, if we were reading the directions a little closer, we would say that yes, it's a proportion, but there we go. If you cross multiplied, that is another fine way of doing this problem. You would multiply 30 by 50, you get 1500. You would multiply 125 by 12 and you still get 1500, so you still get a yes. So this is how you check to see if a proportion is true, if two ratios really do equal one another. Raise your hand if you have any questions. Next, we're going to talk about how we actually solve proportions. So typically when you see proportions, there's one value that's missing. Remember in algebra when we don't know something, we use a variable like x or y or w or p. So in these, you're going to have one part of the proportion that's missing. Your goal is to solve for that variable. Here is how we solve. We do that same trick. We cross multiply. And then we solve the equation that you get just like normal, just like we did first semester. If it has an x squared, we'll use the tricks we learned last chapter. But either way, you solve just like any old equation after you cross multiply. So let's look at number 3. I want to start right here and I want to multiply across the equal sign. So what is... Yes, that gives you 18x. Good. That's going to equal whatever I get when I go across this way, which is 2 times 9. Now, if you want to start at the 9 and go down to the 2, that's fine as well. It doesn't really matter on the order here since it's multiplication. What do you get on that side of the equal sign? 18. Good. Now, if you want to say in your head 9 times 2 and x times 18 and go right to this step, I'm okay with that. For today, while you're learning though, I'm going to write out what I'm actually multiplying so you can see where I got these numbers. Any questions so far? Alright, so now I have this equation that I need to solve just like normal, just like first semester, just like last chapter. 18x equals 18. I want to know what x has to equal to make this true. So what do I need to do to both sides? Yeah, divide by what? Yeah, whatever's bothering the x. This is 18 times x. We want to get the x by itself, so we have to undo the multiplying by 18. We undo multiplying by dividing. Divide both sides by 18. I'm left with just an x on the left side. What's 18 divided by 18? 1. So my answer is x equals 1. Now, if you want to check your work, you can plug the 1 in right here and then do what we did on example 1 and 2 to see if they're equal. But that's only if you want to check your work. That's why I showed you 1 and 2, just so you know how to check your work. There actually are not examples like 1 and 2 on the homework. It's just something that might be useful for you as you're going through these. The homework will all look like 3 through 8 though. Any questions? Alright, on the next one, I am going to do 16 times 5 when I multiply that way. And that's going to equal x times 8. What is 16 times 5? 80. Equals, what's x times 8? 8x, yep. Yeah, I always stop top right, bottom left, no, top left, bottom right. bottom left, top right. It does, honestly, if you did 8x, if you went this way first, 8x equals 80, you should still get the same x value as we do. Alright, now focus in on just this line. 80 equals 8x. How do I get the x part by itself? Divide both sides by 8. On the left side, what is 80 divided by 8? And what happens to these 8s? Yeah, and we're just left with the x. So your answer here, you could leave it 10 equals x. You could rewrite it x equals 10. It's up to you. Raise your hand if you have any questions. Alright, on number 5. First, I want to do 10 times 5. That's going to equal 3x times 2. What is 10 times 5?
50.
What is 3x times 2? 6x. Good. How am I going to get the x part by itself? Divide by 6. Does anyone know what 50 divided by 6 equals? 8.33333. The way you show 33333 is to put a bar over it. So this is 8.3 with a line over it. Typically we write the x part in the front, so I'm just going to flip-flop this. X equals 8.3. And we're done. I will caution you though, I feel like I will shortchange you if I don't make this little public service announcement. Some algebra teachers do not like decimals. So you might have an algebra teacher in the future that would make you simplify this fraction right here instead of making it a decimal. So another acceptable answer would be 25 over 3 because I am just reducing this fraction since it won't give me a whole number. Okay? So in future algebra classes, you will probably have to submit your answer like this. However, in my class, decimals are fine. If you're getting the right answer, I'm not going to be picky about how you got there. All right? Any questions? Number 6. What are the first two things I need to multiply? Y and 12. What are the next two things I need to multiply? 21 and 4. What is y times 12? 12y. What is 21 times 4? 84. And how am I going to get the y part by itself? Divide 12 by both sides. Or divide both sides by 12. Sorry, I said that backwards. Correct. 7 is our answer for the y. Again, if you want to plug the y part back in and then double check to see if 7 over 4 really does equal 21 over 12, you can totally go for it. Any questions on number 6? All right, here's number 7. How should I start that one? You want to go this way? I'll go. Colin wants to mix it up. I'm going to go with Colin on this one. He wants to start on the bottom left and go to the top right. So he wants to do 2x equals 3 times 4. Is that the way you want to do it? If you have 3 times 4 equals 2 times x, that's the exact same thing. Okay? And if you don't believe me, go through your steps. I'll go through my steps with Colin, and we'll see if we get the same answer. 2 times x is 2x. 3 times 4 is 12. Whoa, 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 whoa. How do you undo multiplying by 2? You must divide by 2. So here x equals 6. Very good. You're still, if you're getting 24, you're multiplying by 2. You do 12 times 2? Yeah, you gotta divide. But if you were plugging back in to check if your answer was right, you'd catch your mistakes. But you know. I understand a lot of you probably won't do that. Alright, last example of the day. I'll wait for someone to tell me how to do it. X times 2 equals 8 times 1. Yeah, so 2x equals 8. And then what? Divide both sides by 2. And what does x equal? 4. Very good. Alright, that's all I've got for you today. Here comes your homework, as long as there are no questions.